So topic 13 is more simplifying using the properties of exponents, except all of these problems will have multiple variables in them. But honestly, it's the same concept. It's utilizing the same properties. So as a refresher, let's talk about the properties again. Let's list them out. We know that there is the product property, which says if you multiply two exponential expressions with the same base, you can merge them together by adding the exponents. The quotient property says the exact opposite. If you're dividing two exponential expressions with like bases, you can merge them together by subtracting the exponents. It's always the top exponents minus the bottom exponent. And then the power property says you can stack exponents on top of each other, allowing you to multiply them together. So those are the three main ones, and of course we have two other important but not as used often properties. We have the negative exponent property, which says that if your exponent is negative, the only thing that negative does is reciprocate the base. It moves the base, whether it moves to the bottom or if it was already on the bottom, moving it to the top. And finally, my favorite, the zero exponent property says almost anything to the zero power is 1. Now when it comes to simplification, you're primarily going to use the first 4. Now I did give suggestions on how to simplify expressions involving exponents. Like I said in topic 12, there is no blueprint. There is no step 1, step 2, step 3, but these suggestions should get you at least started if you're completely lost. I suggested the first thing you should always do is break down parentheses, and that's usually with the power property, with the exponent property. After that, if a problem is just too overwhelming for you, go ahead and simplify the numerator and denominator separately. And that's almost always going to be the product property, the multiplication property. And assuming you did that, assuming you'd work the numerator separately and the denominator separately, you should be only left with one other step, which is to apply the division property if it is a fraction. Sometimes your expression won't have fractions and you can skip this step. So in topic 12, we did these very 3 steps with expressions that only contain one variable. So how does it change if you have multiple variables? Just focus on one variable at a time. Do not mix the letters. If the letters are different, you can't do anything with them. For example, suppose I ask you to simplify, let's see here, x to the 4, y cubed, z to the negative 4, all over, parentheses x, y to the negative 2, z to the 4, parentheses to the negative 1, times 2, x to the 4, y to the 4, z cubed. So very similar to what we did yesterday, just you have more variables. That's okay. So if you were to follow my suggestions, the first thing I would do is take care of any parentheses, and I only have one set of parentheses here. So applying the power property, I'm going to distribute that exponent of negative 1 inside to every single exponent. The rest of the problem, I'm not going to do anything with them, so I'm just going to copy them down. I didn't do anything with the numerator, so copy them down, over, and then if we distribute the exponent, negative 1, the exponent of negative 1 to the x gives the x a negative 1 exponent. A negative 1 times a negative 2 becomes a positive 2, and a negative 1 times 4 becomes a negative 4. We did not do anything with this guy, so just copy him down. Times 2x to the 4, y to the 4, z cubed. Next, following my suggestions, we're going to tackle the numerator and denominator separately. And that's usually the multiplication property, the power property, product property, excuse me. Notice in the numerator, there's nothing to do. There's no multiplication going on. They're all different letters. So again, just copy them down. There's nothing for you to do there. Now in the denominators, there's lots of stuff going on. Now here's the cool thing. These properties only work for the same base. So don't get too overwhelmed by all these x's and y's and z's. Just focus on the same letters at a time. Just look at the x's together. Look at the y's together. Look at the z's together. The first thing I do notice is that we do have this rogue 2 here. This 2 is off by himself. He doesn't have a buddy 2, so just write him down because there's nothing to do. Now focus on the x's. Here we have x to the negative 1, x to the 4. According to the multiplication property, you add the exponents. So a negative 1 plus 4 gives us a 3, x to the third. Let's take a look at the y's now. We have y squared, y to the 4. According to the product property, you add the exponents. 2 plus 4 is 6. Y to the 6. And last but not least, the z's. Z to the negative 4, z to the 3. Multiply them together. You have to add the exponents. Negative 4 plus 3 is a z to the negative 1. Okay. Finally, my last suggestion is to do the division property, the quotient property. And again, the property says when you divide like bases, you subtract the exponents. I'm going to just do top minus bottom. Now again, this 2 is off by himself. He doesn't have a buddy to do any properties with, so he just stays put. And since he was already in the bottom, I'll keep him on the bottom. Let's work with the x's. When we subtract top minus bottom, 4 minus 3 is 1. Let's do the y's. When you subtract top minus bottom, 3 minus 6 is a negative 3. Let's do the z's. Top minus bottom. When you do 4 minus a negative 1, that becomes a positive 5. Technically, this is the right answer, but the instructions on the practice will say keep your exponents positive. So the last thing we need to do is take care of any negative exponents. And according to the rule, if your exponent is negative, you have to move him across the fraction. So my final simplified answer, the x will stay put, the z will stay put, the 2 will stay put, but the y cubed goes down. Notice I didn't do anything crazy or different or special. I just applied the same properties as topic 12. I did the same suggestions as topic 12, except you have more variables. Just take it one variable at a time. I'll go ahead and just do one last example, just so you guys can see another example worked out. No rhyme or reason why this is special. This is just a completely random problem. I'll try to make it look as ugly as possible and see that it's quite straightforward. So suppose I ask you to simplify. Let's wrap the whole guy in parentheses, fraction bar, 2p to the negative 1 times parentheses m squared p squared q to the 4, close the parentheses, cubed, close another parentheses, cubed, all over q p to the negative 1. Isn't that ugly looking? But let's just follow the same tips and techniques. Suggestion number 1, break down any parentheses. And as I said in topic 12, if you ever have parentheses within parentheses, you do the inside first. So my first step, I'm only going to do this guy because he's the inside parentheses. Everything else, I'm going to leave alone. So equals. The big parentheses, I'm going to leave alone. The 2p to the negative 1, I'm going to leave alone. But I'll go ahead and distribute the smaller parentheses. So 3 times 2 is m to the 6. 3 times 2 is p to the 6. 3 times 4 is q to the 12. Everything else stays the same. Now I still have the big parentheses, so we got to take care of him. Equals 3 is as an exponent gets distributed to the 2. Now, do not make the mistake. A lot of kids like to write 6. But remember, this 2 is a regular number. This 3 is an exponent. So you got to give the 2 an exponent of 3. 3 times a negative 1 is a negative 3. M to the 6 times 3 is m to the 18. Same thing with the p, because it also has a 6. And then for the q, 3 times 12 is a 36. All over, you got to distribute to the denominator as well. So 3 to this q is q to the third, and 3 to this negative 1 is p to the negative 3. So yes, I mean, these problems will get big, I'm not going to lie to you, but it's just, if you take it slow and steady, one step at a time, same suggestions. So step 1, break down the parentheses, done. Step 2, I'm just going to work the numerator and denominator separately. Notice how the denominator is just a q and a p, there's nothing to do. So when I do this next step, the denominator will stay the same. It's not, there's nothing to change there. So in the numerator, remember, these properties only are valid if they have the same letters, so do not mix the letters. First things first, this 2 is by himself. He doesn't have any of the buddies, so he just stays put, 2 cubed. And let's work with the, let's go alphabetical order. Let's do m's next. Well, see, this m is by himself. He doesn't have a buddy, so just copy him down. Then next will be the p's. So we have p to the negative 3 times p to the 18. Property says when you times like basis, you add the exponents. So negative 3 plus 18 is a 15. And then lastly, this q is off by himself. There's no other q's on top. So you write 36. Just copy them down. Finally, go ahead and do the division property only with the same letters. So equals, the 2 again is by himself. The m again is by himself. So let's do the p's. So 15 minus a negative 3, be careful when you're subtracting a negative, that's actually going to give you 18. Let's do the q's. 36 minus 3 is 33. And there's nothing left. There's no negative exponents. We're all peachy hunky-dory. That is the simplified form. So I hope you find that topic 13 is very similar. I would even argue identical to topic 12, except you have multiple letters. Just keep practicing until you get the hang of it.